things on its own. So for example, if one of the engineering agents creates some code, it'll send it to the user proxy agent, who can then either send it to the human for approval to run the code, or it can auto approve and run the code itself. Then we also have this assistant agent, which is just kind of the most default version of an agent that you can have. And the assistant agent is the one that is actually going to be writing the code in the example that we just discussed. So here it says a user proxy agent and assistant agent from Autogen can be used to build an enhanced version of ChatGPT plus Code Interpreter plus plugins. The assistant agent plays the role of an AI assistant like Bing Chat or
YouTube.
ChatGPT. The user proxy agent plays the role of the user and simulates users' behavior, such as code execution. So if that user proxy agent weren't there, the assistant agent would pass me the code, and then I would open a Visual Studio Code, for example, and just run the code. But now that we have that user proxy agent, the user proxy agent can actually run the code itself, saving me time. Autogen automates the chat between two agents while allowing human feedback or intervention. The user proxy seamlessly engages humans and uses tools when appropriate. So another thing it can do is ask me for input. So as all of these autonomous agents are working together, at any point I can say, okay, this is the point in which you want to ask the user, the human.
Yeah.
For input as part of this process. Now on the GitHub page for Autogen, they give a bunch of different examples and the code for them using Google Colab. And so we're going to review a couple of these as the way to teach ourselves how to use it. So the first one says automated task solving with code generation, execution, and debugging. That sounds like a great one. Let's try that one. Okay, so I have my Google Colab loaded up. This is the templated example that Microsoft provides. I'll drop a link in the description of all of these examples that we go over today. So it says, in this notebook, we demonstrate how to use assistant agent and user proxy agent to write code and execute the code. Here, assistant agent is an LLM-based agent that can write Python code in a Python coding block for a user to execute for a given task. So this is essentially Code Interpreter, but on steroids. And if you remember, as you're using Code Interpreter, if it runs into any problems, for example, if it writes some code and it gets an error or a bug, it can iteratively fix itself. And that's the beauty of the multi-agent framework. User proxy agent is an agent which serves as a proxy for the human user to execute the code written by assistant agent or automatically execute the code. So again, usually if there were code output, I would have to copy the code, put it in Visual Studio Code, and then execute it. But in this example, user proxy agent can actually run the code for me. And it can either ask for my approval to run the code, or it can just run the code automatically. And there's a setting for that, which I'll show you. Depending on the setting of human input mode, and that's where we set whether you need to actually give approval or not, and max consecutive auto reply, the user proxy agent either solicits feedback from the human user or returns auto feedback based on the result of code execution, success or failures, and corresponding outputs. Then assistant agent will debug the code and suggest new code if the result contains error. The two agents keep communicating with each other until the task is done. So I'm going to be showing you all of this through Google Colab, but you can easily run this locally as well. The first step is right here. We're just going to install the PyAutogen library. So pip install PyAutogen. So I just removed the commenting and then I installed PyAutogen. Next, we're going to set our API endpoint. And this is where you can plug in other APIs. If you want to see me create another video where I show you how to use Llama 2 specifically with Autogen, let me know in the comments. So here we just import the library, import Autogen, and then we're going to have a config list. And so we say Autogen config list from JSON, and then we pass in a JSON object. OAI config list is just the name. And then we have the filters. So we're saying the model can be any of these models. And here's what the config list looks like. And you can have multiple API endpoints. So you can actually use multiple models, it seems. So here we have model GPT-4, and we're going to input our API key right here. So I go to OpenAI again, and I go to the API keys section. And if you don't already have an OpenAI account, go ahead and sign up. Click create new key, and I'm going to type in Autogen as the name, and it's going to import Autogen, and then it's going to set up the configuration for me. Okay, should be done. And so here it is, example task, check stock price change. And so what this is going to need to do is actually write code to go check the stock prices and then present it to me, the user. So here's where we're going to be defining our different agents. The first agent is the standard agent, the assistant.
So it looks like here he creates a variable called assistant, and it's equal to, he's pulling a library from Autogen, and he's assigning it to the assistant agent from the Autogen library.
And so we say assistant agent, that's one of the standard agents. Autogen.assistant agent, name assistant.
The variable name equals assistant, it's a string text. This is a large language model configuration.
LLM config, and this is where we actually write.
I'm not sure what the fuck the seeding is.
Some configuration about our LLM.
The temperature, yeah.
LM. We use seed 42, and seed is for caching. So it actually tries to cache some of these prompts that it's going to be using. So if we have 42 over and over again, it will not actually call the LLM again and again. It'll just use the cached version. Then we pass in the config list, and then the config list reads from the config file, and then we have the temperature. And of course, as always, the higher the temperature, the more creative the result, and the lower the temperature, the more standardized or less unique the result is going to be. Then we also have the user proxy agent. And as a reminder, the user proxy agent represents the user, so represents me, the human user. But it can also do things on its own. So here we call it user proxy. The human input mode is never, and so that means it's just going to execute code as it gets it. It's not going to ask me for approval. And so really quickly here, it says the human input mode options are always, so basically it can also do things on its own. So here we call it user proxy. The human input mode is never, and so that means it's just going to execute code as it gets it. It's not going to ask me for approval. And so really quickly here, it says the human input mode options are always, so basically at every single step, ask for input. Terminate, which means only during termination does it ask for input, only when it's done. And then never, which means don't ever ask for input from the user. Max consecutive auto reply now is set at 10, and that essentially means the number of back and forths that we're going to allow before the task terminates. So 10 is fine. Obviously, the larger it is, the more you risk the agents going back and forth without any human input. Then here we say what the is termination message is. And this is just really the logic to understand when the termination actually occurs, when the task has been completed. Then we have the code execution config. So we have the working directory coding. Then we say use Docker false, so it can use Docker. And then here's where we actually kick off the dialogue. So it says user proxy, and it always starts with user proxy, initiate chat. And we're going to initiate chat with an assistant with the message, what date is today? Compare the year-to-date gain for Meta and Tesla. And so that is the task that we're giving it. And keep in mind, you can define as many agents as you want to work together, and you can give them all individual unique roles. So now we run it, and there it is. It's going. What date is today? This is the user proxy. This is me asking it. This is if I were to prompt the large language model. What date is today? Compare the year-to-date gain for Meta and Tesla. So it is figuring out how to do that. Most likely, it's going to have to search the web for that information of what the stock prices are. And then it's going to maybe put together a graph or just tell me. All right, here it goes. So the assistant to the user proxy, remember, this is a conversation. First, let's get the current date using Python. So it writes some Python code to get the date, and today equals date.today. That's fine, and it prints the date. Next, we need to get the year-to-date gain for Meta and Tesla. We can use the Y-Finance library in Python to get the stock prices. Please install the library if you haven't done so by running pip install Y-Finance in your terminal. So this is the assistant telling me to install that library. However, the user agent is going to jump in and do that for me. And it actually gives me the code. Here is the Python code to get the year-to-date gain for Meta and Tesla. So it writes the code, import Y-Finance, from date time, import date time, get the current year. There it's using that library. So it actually wrote the code. And here it says this code will print the year-to-date gain for Meta and Tesla in percentage. Now, here's where the execution actually occurs. So this is the user proxy, aka me, but an agent on my behalf executing the code. And we got a bug. So here we have a bug and we pass it back. See, it says user proxy to the assistant. We pass that issue back to the assistant to try to fix it. And here it is, the assistant back to the user. I apologize for the oversight. The variable today was defined in the first code block, but not in the second one. Let's correct it. So there it is. It is actually correcting it. Here we go. Here's the new code. And here's the code output. So it looks like it actually worked this time. There it is. Meta year-to-date gain, Tesla year-to-date gain in percentage. And then the assistant back to the user says, great, the code has been executed successfully. And then the assistant basically packages up the information in a really nice, readable way. So as of October 2nd, 2023, that is today, the year-to-date gain for Meta is approximately 140%, and the year-to-date gain for Tesla is 131%. This means if you had invested in these stocks at the beginning of the year, your investment in Meta would have increased by about 140%, and your investment in Tesla would have increased by 131%. Please note that stock prices can fluctuate and the actual gains may vary. Terminate. Now, the assistant knew it completed it successfully, and then it output the terminate response, which stops the conversation completely. This is incredible. It's a very simple example, but it really shows you the power of Autogen. Let's say we want to actually plot a chart. So let's continue. We have user proxy sending a message. The recipient is going to be the assistant. Plot a chart of their stock price change year to date and save to stock price ytd.png. Let's run that. We're just continuing the conversation. We don't have to restart the entire prompt. So first, the user proxy, me, to assistant. And then it's saying what this prompt is. Okay, let's take a look at what the output is. So assistant to the user. Sure, we can use matplotlib library in Python to plot the chart. If you haven't installed it already, you can install it by running pip install matplotlib. We don't have to do that. The user proxy agent is going to do that on our behalf. And the assistant writes the code for us. So here we go. We're going to import it. It also tells us how to install it. And then it shows how to actually output the data in a chart format. And we have an error. So metadata normalized, name metadata is not defined. So the user is going to pass the error to the assistant. Then the assistant back to the user says, I apologize for the oversight. The variables metadata and Tesla data were defined in the previous code block, but not in this one. Let's correct it. And here we go. We have updated code now. Then it runs it again. User proxy to assistant. It actually completed it that time. Excellent. Okay, now we have stock price ytd.png. And now let's display the generated file. Let's go ahead and do it. So I just ran this. This is fresh from the code that I just ran, and it worked. This is absolutely incredible. How amazing is that? Now anybody can create a multi-agent environment so easily. I want to show one more example because this one is so cool. This next one is auto-generated agent chat teaching. This notebook demonstrates how Autogen and
agent teaching.
enables a user to teach AI new skills via natural agent interactions without requiring knowledge of a programming language. So basically what we're going to do is we're going to create new skills for these agents that they can use over and over again. So as always, we're going to start with pip install Autogen. So right here, I'm going to go ahead, remove the comment, and then run it. All right, there we're done. Now we're going to set our API endpoint. We're going to import Autogen. We're going to set up the LLM config. All right, so I just changed a couple things in here. We're going to do it simply instead of having a separate file. I'm just going to put this config list right here. Then we load the config list into this LLM config. Hit play. Then let's run this block. Done. Example task, literature survey. We consider a scenario where one needs to find research papers of a certain topic, categorize the application domains, and plot a bar chart of the number of papers in each domain. So first, we're going to construct our agents. Here, we have an assistant agent, and we have the user proxy agent just like normal. And there we go. We set them up. And let's run this block. Done. Now we do step-by-step requests. So here we say, find ARXIV papers that show how are people studying trust, calibration, and AI-based systems. And there we go. Now, of course, you can define all of this in separate files and then load the files, but we're going to do it simply by just including it in the code. And here we go. Find ARXIV papers that show how are people studying trust, calibration, and AI-based systems. And the user is initiating the chat. And now the assistant is probably working with that. Here we go. To find ARXIV papers related to trust calibration in AI-based systems, we can use the ARXIV API. So it has no information about what the ARXIV API actually looks like, but it's going to assume some stuff, and here we go. So it writes some code to do that. Here it is, the export right there, and it's basically just going to scrape that. It's going to tell me everything I need to do. Then the user proxy is going to actually execute the code, and here we go. It looks like it's actually grabbing some papers. This is absolutely so cool. And here we grab a bunch of different papers. The Python script has successfully fetched the information about ARXIV papers related to trust calibration in AI-based systems. Here are the titles of the paper, their authors, a brief summary, and a link to the full paper. So it looks like we got a list of 10, and we can actually click into each of them if we wanted to. Then we got the terminate command. So far what we have is a list. Then we continue the task. Task 2, analyze the above results to list the application domains studied by these papers. Let's do that. So it's probably going to actually need to read the papers. So let's see how it decides to do that. Okay, here we go. Assistant. Based on the summaries of the papers, here are the application domains that these papers have studied. I'm not actually sure how it analyzed the papers. I would think it would have to write some code to actually go analyze the papers, but maybe it just read the summaries. Okay, so now we have the summaries. Then task 3, use this data to generate a bar chart of domains and number of papers in that domain and save to a file. Do that now. Now the assistant says to generate a bar chart of the application domains and the number of papers in each domain, we can use matplotlib library in Python. Here's the script. So it provides us the script. Perfect. Then the user proxy executes the code, and it looks like it executed it successfully on the first try. And terminate. The Python script has successfully generated a bar chart showing the number. There we go. Now let's uncomment this and let's look at the bar chart. Okay, so it looks like it named it something different. So I'm going to grab that name and I'm going to put it right here and let's play it again. There we go. Unbelievable. That was easy. Okay, now we're done. Next, we're actually going to create a recipe, basically a learning, a piece of knowledge that can be used over and over again to do something very similar. Now that the task is finished via a number of interactions, the user does not want to repeat these many steps in the future. What can the user do? A follow-up request can be made to create a reusable recipe. So task 4, reflect on the sequence and create a recipe containing all the steps necessary and a name for it. Suggest well-documented, generalized Python functions to perform similar tasks for the coding steps in the future. Make sure the coding steps and non-coding steps are never mixed in one function. All right, let's see if it works. I mean, it's so cool. It's so meta. Not Facebook meta, but actually meta. And once we have this, we could technically store it locally, and we're caching some of it. So this actually becomes extremely efficient to run. Okay, here we go. Sure, let's create a recipe for the sequence of steps as followed. And it lists out the sequence of steps and it returns all of this code. Beautiful. Great. It seems like Python functions for fetching papers from ARXIV and generating a bar chart have been defined successfully. You can use these functions in the future to perform similar tasks. Remember to perform the non-coding steps manually in your language. Okay, terminate, done. Now we can reuse the recipes if we wanted to, but I'm going to go ahead and skip that step. So that's it. If your mind isn't blown by this, I don't know what's going to blow your mind. This is absolutely incredible, and I'm just scratching the surface. Let me know in the comments if you have use cases that you want me to explore with this that I didn't touch on today. If you liked this video, please consider giving a like and subscribe, and I'll see you in the next one. In this video, I'm going to show you how to get open source models working with Autogen. It's really easy, it turns out. And you can basically get any model you want working with it in minutes. The hardest part is actually figuring out which model is going to work well and then adjusting the prompt template to get the agents to actually do what you want them to do. So I'm going to show you how to do it. Let's go. The first and only thing you need is LM Studio. And LM Studio, I had never heard of, and it's absolutely incredible. It allows you to download any open source model and run it on Windows or Mac, and it's really fast. It comes with its own chat interface. You can run inference on it. You can spin up a server, and that last part, the server, is what we're going to use to power Autogen. So come to lmstudio.ai and download whichever version you need, either Mac or Windows. I've downloaded both and I've gotten it to work on both, but I'm going to use Mac today because that's what I'm recording this video on. Once you download LM Studio, install it, and this is what you're going to be greeted with. Right here, you can actually just search for any model that you want.
No.
So we're going to be using Mistral. I hit enter and it lists all the different versions of Mistral that are being hosted on Hugging Face. So the specific one we're going to be using is this one right here, which is actually a new and noteworthy model. Mistral 7B Instruct version 0.1. And like I said, test different open source models and figure out which one works best for Autogen for your use.
Do you have any edibles? Do you have any edibles? Do you have any edibles? You do have edibles.
Use case. All right, and right here we have the Lopes version, and we can see how many downloads, how many hearts. So we click on that, and then we can see all the quantity.
Oh, she smacked you in the mouth?
She smacks me in the mouth.
Bitch, don't kiss me. I don't roll like that, homie. Tell her. See, we are not what you think.
We are not gay.
Yeah. No gay. No gay. She said no gay. No lesbian.
You have your water?
I don't need a water, nigga. That's not the same edible.
Huh?
I don't need a water, nigga. Oh, it is that same edible. It looks like it's in a jelly container. That's weird, huh?
It's jelly.
That's how you know it's potent.
It's jelly. And it's not even cut up.
Let me see that.
Okay. So there's 2
It
left.
tastes like straight up like resin.
So
like
there's
if you're
2
just
left.
eating resin. For you.
For me. Because this is my last packet. We went through 4 of these?
You have a problem, babe.
Bitch, that's you. I don't get high and talk to the kids go to sleep. So fuck.
Let's start blaming her. You have a problem.
Now, I usually use the Q5, but there's no reason you can't use a larger version. The Q5 works really well on my MacBook Pro M2 Max.
For no reason.
Very, very fast. So once you click here, you're going to come over here and you can just click download. The download will take a few minutes. I'll show you what that looks like. And so let's say I wanted to download the Q6 version. I come here and I just click download. Then I click here and you can actually see the download progress. It is so easy. I'm so glad I found LM Studio. Not only that, but it has the chat interface built into it. Here are all your settings that you can use, prompt format, everything you need to run these models locally. This is by far the easiest way that I've found so far. But what we need to do is actually set up a server. So over here, we're gonna click this little local server button, and then all we do is at the top, description below. So what we actually need to change is within this config list. The AI type, we're gonna keep as OpenAI. The nice...
Stop jumping around. Give me a kiss.
Today, the Autogen fun continues. In this video, I'm going to show you how to set up Autogen using a fully open source model, but using RunPod to host that model. And that means you can run even the largest open source model and have that be your agents powering Autogen. It's amazing. And we're going to be using text generation web UI to power the API, and it is completely open source this time. You can follow these exact same steps to get it set up on your local computer, but I'm going to show you how to do it on RunPod. Let's go. I've put together a number of tutorials about RunPod. I'll drop it in the description below, so I'm going to go through this initial part quickly. But as usual, you're going to click over here to the Secure Cloud tab. You're going to make sure you have run pod the blokes LLMs template right there, and I'll link that in the
Fucking
description
nigga,
below.
go
Then
away.
we're gonna scroll down, and we're actually gonna get this
God.
RTX A6000.
You're
Go ahead
tripping.
and
Excuse me,
is
Jacob?
5001. So once you do that,
What?
you're gonna click.
Excuse me?
This is a relatively small
This
model.
little nigga's trying to fucking trip me. Like, what the fuck?
Little nigga.
Fucking cat.
Welcome back. Today we have another video on Autogen.
You know,
Have you ever
it's like,
seen that
walking
movie?
right in front of me.
Have you ever seen that movie called Me, Myself, and Irene?
Yeah.
Remember that dude, he gets married to his wife and then she cheats on him with a black midget?
Yeah, and then she fucked that midget black guy.
Yeah, the midget. And then she had babies, like little black babies, and he called them his son. Shit.
This is the advanced tutorial.
Okay.
We're gonna go over
They're like three black kids and he's a white guy. He's like,
I'm
my
gonna go in
boys.
depth. I'm gonna show you some code. I'm gonna go through the documentation, and by the end of this video, you're gonna be able to build incredible
And then she left her kids
things with
behind.
Autogen. And
Yeah,
I
she
realized
left- she
while
left that
doing the
nigga and her
research for
kids
this
with
video,
that
there's
dude.
topics in Autogen that are expert level and warrant another video.
He's all
So
waving
I'm
to
gonna
his
be
wife. Have a
creating
good time,
another
honey.
video, an
I'll take
expert
care of these
tutorial
boys.
for the remaining topics that I don't cover in this video. But for this video, I'm covering
Nugget.
almost everything in Autogen.
I
it
thought
turns
that's
out
the little guy you were
Autogen
talking
has
about,
a
little
ton
black
more
midget.
functionality than I even realized when I first started playing with it.
Okay.
In fact, it is incredible as a drop-in.
That nigga didn't even fight that
replacement for
nigga.
your
That nigga doesn't
ChatGPT
want to smoke with me. I
API
just
if
kick
you
him in the
wanna
head.
use that. And stick around to the end of this video
This
because
guy.
we actually have a brand
don't
new
wanna smoke.
agent type that
So
we're
he's
going to
gonna
be
fight the
talking about
midget.
that was just released by the
Kick the
Autogen.
midget straight in the
So
face.
let's
No
go.
one smoke with me,
The
nigga.
first thing I want to talk about is the LLM config and the config list
See that
parameters.
nigga.
Trying to get that nigga brain
The config
damage.
list parameter is something that's passed into the
That's
LLM
what sucks about
config.
being a
First,
midget,
let's
is,
start with LLM
everyone's
config.
kneecap is
That
at
is
your face,
something that
like,
is
so
passed
easily just
to
get
each
kneed in the
agent,
face, he's a
and
midget.
it doesn't matter if you're creating an assistant agent or a user proxy agent. They all take LLM config, and there's a bunch of different settings that you can play around with for
They all
LLM
take
config.
LLM
So here's a few.
config.
The main
See,
thing
that's
that you're
what I
gonna
gotta
be
get
passing
better
into
at too,
LLM
dog. I gotta
config
start
is the config
knowing how to
list, and that's
do
where you
LLM
define
configurations,
which
like,
models
on
that you want
different
to
models
use and
and
how to
shit.
set up those
That way I
models.
can
And you can
get them
have
to
a
do shit.
daisy chain of models that you want to use. So let's say you start with GPT-4, then you have an open source model, then you go to GPT 3.5. And it'll actually fall back depending on if it gets an error or not. But you have some additional functionality that you can put in LLM config. So here's the first one, context. And if you're going to be using prompt templates,
I just
this
popped
is
an
where
edible,
you'll
little
be
nigga.
defining
You know
the
about that?
keys for that template. Now I'm just going to touch on prompt templates.
a little
and I'll
edible,
probably
little
save
nigga.
the actual
Little
deep dive
edible.
into
Popping
prompt
perks like,
templates for the expert tutorial.
Kodak
So
Black
here's an
on the
example.
live stream.
If your prompt is
Yeah,
complete
trick
the
shot, the
following
edibles.
sentence and then this prefix, you can actually pass in the prefix
Yeah,
just
dude,
like
actually
that.
did that
So
on
you
a
say
live
the
stream.
prompt, here it is, and you pass in the context
Like on
equals,
Carson
and
Nance
then you
live
pass
stream
in
too,
the keys.
like,
So
damn.
prefix is today I feel. And then here it says the actual prompt will be complete the following sentence today I feel. So the context
What would
is
you
where
do,
you can
Nero, if somebody
define
did that
different
on your live
variables to
stream?
insert into the
Autogen
prompt.
right there.
So here it is problem, how many positive integers not exceeding 100 are multiples of 2 or 3 but not 4. And then the actual prompt is
Nero
right
would pop
here,
one with
and
him.
we insert the problem, which is defined in the
Fuck.
context, into the prompt. And then we end with solve the problem carefully. We can also say solve the problem step by step. And that just makes it super easy to create
That nigga
different
Kodak
prompt
Black's a
templates for
professional
different
pill
agents. So
popper.
you're not
He does
rewriting
trick
the same
shots
thing
with them.
over and over again.
So
Next is a use cache
Pretty
allow,
professional.
and that allows you to either use the cache or not. So by default, cache is enabled. So if you don't put anything, it's going to be enabled. But if you don't want to use the cache, such as if you're doing a lot of testing and you actually want to see the replies
name is
back
Kodak Black,
from
but when you see him,
ChatGPT
he's
or your
white.
open source model, then you would turn that to false, and it's true or false. It's a boolean. And then, like I
never
mentioned,
understood that
config
joke.
list, and this is a list of configurations
When you
for
see
the
me, I'm
completion
white.
you
It's
try.
like,
The
what?
first
How
one
are
that
you
does
white?
not raise an error
You're
will
black.
be you.
Hey,
So that's where, as I
Don't be
mentioned,
pausing
you
my
put your
videos.
daisy chain of large language models
pausing my
that you
videos,
use
little
and all the
nigga.
settings associated with that. But this
Little
is
baby,
also where you're
little
going to include
baby.
your function definitions.
give me
And
love.
one of the most powerful features
me
in
love.
Autogen is its ability to
Love
use
me.
function calling. And if you're not familiar with function calling, it's just a way
baby
for you to
loves you.
predefine functions for your Autogen or large language model to use. So you can predefine
Little
functions in a
nigga.
certain format, and then you can actually write the functions in the code and then the large language model can use those functions based on the definition and based on
I can't wait for you
executing
niggas to have
Now,
kids.
I'm going to get into function calling later in this video, so that's all I'm going to say about it now. But in the LLM config, that is where you're going to put all your function definitions.
This nigga said a little menu.
Here's another setting that's super useful. Raise on rate limit or timeout. Now, I frequently get rate limit issues with ChatGPT. Now, obviously, you're not going to get this if you're running an open source model, but if you're using ChatGPT, either 3.5 or 4, you're going to get rate limit issues if you're using it too often. Typically, I'm getting a tokens per minute rate limit. And so what you can do here is you can set this to true or false. When it's true, it's actually going to raise an error and the code execution will stop. But if it's false, then -1, it says right here, -1 will be returned when all configs fail. So it's going to go through the list of different LLMs that you've provided. And if all of them fail, it's not actually going to raise an error. It's just going to return -1. And that allows you to include your own logic for what you want to happen if you run out of large language models to hit because you keep getting errors. And then another option you get is this config parameter. So, and this is specific to the OpenAI API, and it allows you to pass in different parameters that are used with the OpenAI API. And then in addition to those, you also get these 3, which are max retry period, which is the total time in seconds allowed for retrying failed requests. So if you don't want it to just continue retrying indefinitely, you can actually set a time limit on the retries, let's say 15 or 30 seconds. Then you have the retry wait time, and this is the time interval to wait in seconds before retrying a failed request. One thing that it would be nice is if you had an exponential back off, which I'm not sure you do because this is just a single integer. So this is like every 3 seconds you want to wait, or every 10 seconds you want to wait before retrying again. Whereas it would be super nice if you can actually say, okay, 1 second, 5 seconds, 20 seconds, 2 minutes, 6 minutes. But I think at a certain point, it doesn't make sense to just continue waiting. And then you have the seed for the cache, and the cache is super important. I'm going to touch on caching in a few minutes, but this allows you to set the seed value for a cache. So the cache is specific to that seed. I think by default, the example they give is 42. So if you run a prompt with the seed of 42 twice, you don't actually have to hit the OpenAI API a second time or whatever LLM you're using. It's just going to use the cached version. If you change that to 41 or 47 or 2, anything else, it's going to recache it. So that's an excellent way to control your budget and to control caching. And as I mentioned, you can pass in all the different values that you normally can with ChatGPT's API. So you have the model, the prompt, the messages, the max tokens, temperature, top P, and stop presence P.
Screenshot of that shit.
Penality, frequency penality, and best of. So you can pass all of those in. I'm not going to go over those because those aren't really specific to Autogen. All right, now let's talk about the config list. This is where you're going to define all of the large language models that you want to use, whether it's an open source model or a ChatGPT model. And you can do this in a number of ways. You can do this directly in the code, or you can have a separate JSON file that gets loaded into the config list. So if you're going to be loading it in from a JSON file, you're going to be using this right here, config list from JSON. And you're going to call it OAI config list. You're going to define the file location just like that. And you can either have it locally, or if this is deployed to a production server, you just list the URL of where to find it. And then you have the filter dict right here. And the filter dict just tells Autogen which models to look for. And so here's what the OAI config list looks like. You don't need to have it as a separate file. You can literally just pass it directly in, but if you wanted to, this is what it looks like. So this is daisy chain, so it's going to try GPT-4 first with this API key, then it's going to try GPT-4 again, except this time it's going to use the Azure OpenAI API key, and then last it's going to try GPT 3.5 Turbo. And it only goes to the next one if the first one doesn't give a valid reply, such as if it fails or it times out. For each of them, you can include the model, the API key, your API base, which is the URL, the API type. So here it says Azure, but typically you're just going to use the OpenAI API type, especially if you're using an open source model. You just want to keep it standard with the OpenAI API type, and then you can have the API version right here. And by default, it uses the OpenAI API base. So if you did on RunPod. I'll link those in the description below so you know how. And let's put it all together. We have the LLM config, which gets passed into the assistant agent or the user proxy agent. And as one of the values, if we're keeping everything else as default, we just pass in the config list to the config list key. Now, of course, all the previous stuff I mentioned with LLM config, you can do that at the same time. And the nice thing is you can pass all of the LLM configs and thus the config list into each individual agent. So you can have different settings for every agent. And a good use for that is if you're running open source models. So let's say you have a really complex task that you're trying to set up. Let's say you have a team of agents and you have a coding agent, you have a creative writing agent, and then you also have one that needs to do function calling. And typically, open source models are fine-tuned to be good at like one thing. And with Autogen, that's actually a benefit. So you can actually choose the right model for the right task. You can choose the creative writing model for the creative writer. You can choose the coding model like Code Llama for the coder, and so on. So here's some code. Let's actually see what this looks like. So we have two config lists here. We have the CL config list, which is Code Llama. So I specified our local model, Code Llama. I put in a fake API key. And then for the API base, let's say I have Code Llama spun up on a local server and it's port 3000. Then I can actually have a second server, Mistral config list, and we're going to be using Mistral 7B, another fake API key. And then here, I'm putting it on port 3001. So now I have two different models that are spun up running locally, and I can actually assign them to different agents. So here we have our typical user proxy agent, and then for the coder agent, I'm passing in the config list is CL config list, which references this one right here, Code Llama. And then for the assistant agent of the product manager, I'm using Mistral. So I'm going to pass in the Mistral config list. And you can get as sophisticated as you want here. You can have a dozen different models, but of course you need to figure out how to run them locally, and you need to have a powerful enough GPU to run all of them. And you can also mix and match between closed source and open source models. The possibilities are truly endless. All right, now let's talk about caching. Caching can be used both on the agent creation and definition side as well as the drop-in OpenAI replacement side. In the LLM config shown here, we have this parameter seed, and we're going to pass in the number 42. So let's talk about what this does for a minute. Now, in the context of agents, this is how you use it. All you need to do is include this little seed parameter here in the LLM config. So you pass in the config list as normal, and then you pass in seed. And what that's going to do is look over here on the left. We have a .cache folder followed by the number 42. And within that, we have a database, cache.db, and that saves the entire exchange based on the initial prompt. And so why would you need a cache? Well, the good thing is if you're running the same task over and over again for testing purposes, or even in production, if you have everything cached, you're going to save both time and money, because in the case of a closed source model like OpenAI, you don't actually have to hit that API endpoint again and again. If you're using the same prompt and the same seed, then it'll just output the same exact output as it has cached. And in the case of an open source model where cost isn't as much of a factor, you're going to save a lot of time because it doesn't actually need to run the inference against the prompts again because it already has it. Now, there's a few ways to clear the cache. Number one, very simple. Right click on the .cache directory and just click delete. You can also delete specific seeds. So you can right click on the 42 or whatever number you decide, and you can delete it from there. And then the next time you run it, it's going to recache it. Another way to do it is to simply change the seed value right here. So if we want to save that cache but create a new cache, we can change it to 43. We can change it to 123. We can change it to anything we want. And if it's a new seed and it has no reference to that seed, it's going to recache everything and run it from scratch. And on the enhanced inference side, which we'll get to in a minute, which basically means Autogen can be used as a drop-in replacement for the OpenAI API, because it's essentially just a wrapper around that with a ton of additional tools and functionality that are very, very useful. You can use caching just the same. So if you execute the same exact prompt to ChatGPT, you won't actually need to hit the API endpoint a second time if the seed is the same and the prompt is the same. It works just the same as the agent side. And it also has these nice class methods. So if you're using this, you can use this set cache manually. So this allows you to set the cache with a seed, and then it also allows you to clear a cache. But of course, you can simply delete it manually as well, like I showed you. Now let's talk about enhanced inference. Now, Autogen really has two main parts to it. It has the multi-agent conversation framework, and that's really what it's known for, basically being able to define agents that work together to complete tasks. But it has this whole separate thing called enhanced inference, and I didn't even realize how powerful enhanced inference was until I started digging into it. And it truly is a major pillar of the Autogen framework. So let's read a little bit about it, and then I'm going to talk about it. Enhanced inference. So autogen.completion is a drop-in replacement of the OpenAI completion and OpenAI chat completion for enhanced LLM inference. Basically what that means is if you're using the OpenAI API for completion, for inference, you can easily just use Autogen and get all of this additional functionality. And you don't even need to change your code if you already have a code base set up with OpenAI's API. So there are a number of benefits of using Autogen to perform inference. Performance tuning, API unification, caching, error handling, multi-config inference, result filtering, templating, and so on. It is really, really powerful. And I was thinking about this, why would they have done this? It seems to me like the main functionality for Autogen is the multi-agent framework. But as I was thinking about that, to make the multi-agent framework super powerful, actually having all of this additional functionality on the OpenAI API endpoint is really powerful for the agents. And they probably built it and said, oh, look at all this functionality. We should just also package this up as part of Autogen. So I think that's what happened. I don't actually know. And the first thing that we're going to talk about within enhanced inference is the performance tuning. And that basically means finding the best settings for the large language model that you're using. And so here it says the tunable hyperparameters include the model, the prompt, the max number of tokens, the temperature, top P, end, stop, presence penalty, frequency penalty, and best of. So it will automatically adjust all of these settings depending on what your goal is and depending on what the evaluation method is. And so here it explains it really well. The cost of using foundation models for text generation is typically measured in terms of the number of tokens. Yeah, so we knew that. From the perspective of an application builder using foundation models, so a developer, the use
So how the fuck does ChatGPT not have a customer service? It's kind of crazy.
Does ChatGPT know what?
It doesn't have like no customer service or like any way to like call them up and shit.
What do you mean?
You know how like most companies like have a phone number, like a customer service that you call them up and then you talk about like an issue and then they're able to like solve it.
Oh, they do have a support. I think it's like an email, some shit. I don't know what it is.
Cause fucking, I went on my account. I was trying to delete the payment method, and it's like showing that I have, like my card is not on there, and it's showing like when I looked at the history of my billing and shit, it said I had no history and shit like that. So, and it's still trying to charge me. It's kind of weird.
Wait, what?
So I went on my account. I went into the billing. And it shows that I have no card on the account, and it shows that I have like no billing history, which is like weird that it shows it like that. And it keeps trying to charge my card, so I'm like trying to figure out since it.
Are you sure it's the right account?
Yeah, I only have one GPT account that I paid for. That's the same one I've always been using.
The fuck? That's weird.
That's what I'm saying. Like, how does it not pop up in the history or anything? It's like,
And it's still charging your card?
yeah.
You should call your bank and report that.
This nigga, sue this nigga.
No, I'm serious. I'm serious.
Yeah, probably am.
So just call your bank and be like, I try to cancel this shit, and then I'm still getting charged. Like, explain them.
Yeah. They're trying to scam my ass. They're trying to scam broke niggas, bro.
It's like,
Case is to maximize
They try to scam a broke nigga.
I ain't never seen a nigga quite so poor before.
of the generated text under an inference.
Poor?
logical
Oh, he's
string.
poor.
And
Hit him with a
the
late
number of
fee.
dollars
Hit
to
that
solve
with a
the
late
task. Let's say you have a task to create
They
a
love
piece of
doing
code
late
that
fees on
outputs
poor
something.
niggas.
You can actually provide an evaluation method that tests whether the output is correct based on that code, and then you can tune all of these
I ain't
different
never
settings
seen
to
a
figure
nigga
out,
quite
okay,
so
based on
poor.
what I'm doing, what is the lowest dollar value that I can actually get this task completed
never
with.
met a nigga
And
as
so there
poor
are
as
5
you.
pieces of
This guy.
information that tuning can
You
be
the poorest
performed
nigga I
on.
know.
The validation data, the evaluation function, the metric to
Nah.
optimize the search space, and
Yeah,
the
damn
budget.
well, all the
And
niggas
we're
on
gonna
the
talk
Wii
about all
community
five.
that were all
First, the
poor ass
validation
niggas.
data.
They
This
couldn't
is
afford
basically a
Xbox.
set of data that shows what a successful performance looks like. Now, I'm not
Nero's
gonna
laughing
go
'cause he
too deep into
knows.
performance tuning because this is really complex stuff, and I'm gonna
He
save
knows
that
all
for
them
the
niggas.
expert video. And
Oh,
to be
my
honest,
poor.
I'm still wrapping my head around it. So after the validation data, we're gonna have the evaluation function, and this is a
That's
function
what probably
that's
made it
defined
cool
by
is
you
that
that
everyone was on
evaluates
there was
whether the
broke.
output is successful or not. So here we have evaluate math responses, and we have the answer from the LLM, and then we say return success, and then we have this evaluation function is equivalent, and we pass in the answer and the actual solution, and then we compare them against each other. And if the answer that the large language model gave us and the answer we know to be correct is equal, then we pass back success. And what that'll do is once we pass it back, it informs the enhanced inference that that set of variables was successful.
Nigga, I'm so broke that the edible's not even hitting right now.
Budget. Then we have the metric to optimize, and it says here the metric to optimize is usually an aggregated metric over all the tuning data instances. For example, users can specify success as the metric and max as the optimization mode. By default, the aggregation function is taking the average. And then we have the search space. So basically, which parameters do we want to test against?
Yeah,
so we can
Jacob.
test against the model, the prompts, the max
Never
tokens,
met a nigga as
etc.,
poor as me before.
etc. And then we give it a budget. And the
Never
budget
seen a
is
nigga
going
quite
to be
so
in dollars.
poor
So it's going to
before.
try to find the successful combination of different parameters to get the correct output, but to do so within a given budget.
Well,
And
now you have,
the budget
Jacob.
is in dollars, and
Now
it's
you
dollars
have.
for 1,000 tokens. And here's what the actual completed
nigga
code looks
alive.
like. So we have
This nigga.
config and analysis, autogen.completion.tune. So we have our tuning data. We have our metric.
I
of
was a wee
success.
kid,
That's
bro.
what we're measuring against. We want to maximize it. And then we have our evaluation function. We have our inference budget of 5 cents, so 5 cents per 1,000 tokens. We have our optimization budget of $3.
I was so broke.
And then the number of
I didn't even want to get an
and we can
Xbox because you have to
sample
pay
a
for
fixed
Xbox
number,
Live.
But if it's negative
Dude,
one,
me too. I was like, fuck that shit,
The
bro.
PlayStation had free online play.
Bro, niggas had fucking $10 a month every month. What?
Yeah, on
Hell
time,
no.
or you can't play.
Yeah, like what? Exactly. Like that's crazy, bro.
And it had better graphics, nigga. That's crazy.
Barely.
Free online and better graphics.
Oh, the PlayStation had better
Yeah.
graphics?
Yeah.
I wish that Xbox had better graphics.
I still couldn't afford a PS3 back then.
You eventually did, though.
Yeah. Like way after, nigga. Like after its life cycle.
After its life cycle. After
I
the
bought my
PS4 was out.
PlayStation. I bought my PlayStation 3 when Black Ops 1 was out, so it still had life cycle.
Nah, I bought my shit when like Black Ops.
Black Ops 2. It wasn't that late though. It was still active on Black Ops 2.
Well, wait, no, actually, no, it's when GTA came out.
Oh, GTA 5, yeah.
Yeah, GTA 5. That's when I got it.
Wait, we were playing. Wait, what came out first? Was it Black Ops or GTA 5? Or Black
I
Ops
think
2?
it came around the same year. I think it came around the same year.
There's a 2012 first-person shooter. 2012 GTA 5 PS3. Yeah, GTA 5 came out in 2013.
And Black Ops 2 was 2012.
Yeah. Because I remember playing.
Black Ops 1, I think, came out in either 2009 or 2010. I think it's honest, so.
I remember we were playing a lot of Black Ops 2 at first. And then once GTA came out, we were on that shit.
And we can have the problem, we can actually have the task that we want to execute, and then we'll add in.
So see, he didn't get a PS3 after its life cycle, little nigga. We had it. We got the PS3 in its prime. Because when GTA 5 came out, that shit was going crazy, dog.
No, PS3 came out like what, 2009? Like we got it like 3 years later, nigga.
Yeah, but at least we got a discounted price.
Nigga bought that shit used to.
Yeah.
And then you want to add this allow format string template equals true to make sure that it gets inserted properly. So that is really, really powerful, and I encourage you to play around with it. And then last we have logging. It does say logging.
I remember GTA 5 when it first came out, we couldn't even get online because the servers were going down because so many people were on it.
That was crazy, right? The PS3 service was ass.
That was everywhere though, dog. That was Xbox, fucking PlayStation.
Was that Xbox too?
Yeah, there's just so many people trying to get on the Rockstar network. It was fucking crashing.
I don't remember it being Xbox, but I remember everybody shitting on PlayStation that day.
From those sources, and this makes them incredibly powerful. And based on our initial 2 types of agents, we have our assistant agent and user proxy agent. We just add retrieve to the beginning of those to make them
Now you have to do those shitty missions with Lamar in the beginning. I'm not gonna lie, that shit was fun though. I was still DDoSing niggas on that shit. Rockstar. Yeah. So customizing embedding function. By default, sentence transformers and its pre-trained models will be used to... Arrow said it, like if we bought the PS3 like in the dinosaur age or something, like it was... This nigga...
It's not good.
Black Ops 2 was fire though, dude. Not gonna lie, that shit was so sick. That OpenAI_EF right there in our embedding function. So everything goes within this retrieve config. We still pass it the task, the docs path, and the embedding function is something new. Right here we can see we're using Hugging Face the same way. So if we don't want to use OpenAI, we can use Hugging Face. And you can also customize the text script. Yo, Jacob, did you play PS3 back in that day? I usually don't change this, so in this example, all the different text. Wasn't his name Jacob the God? Jacob the God.
Yeah, Jacob's the little PB boy.
I remember when you had your name as Nero the God.
Big PP boy.
Nero the God.
Rewrite our query vector database method. This is all just custom code if we wanted to write that ourselves. But then at the bottom in this retrieve docs method, that's actually overwriting the default retrieve docs method, and that's how you can customize which vector database you use. And again, going really deep into this, I'll probably save for the expert tutorial. But now you kind of get the gist of how this all works. You can customize absolutely everything. And here's a sophisticated example integrating retrieval agents with other agents in a group chat. So like normal, we have the LLM config, and here we define functions. I'll touch on that in a minute. Everything else stays the same. We have the boss, who's a normal user proxy agent. And then we have the retrieve user proxy agent. So this is a user proxy agent that also has the ability to gather information from external data sources. And we want code execution to be false because we just want them to pull information, and we want the user proxy agent, the standard one, to be doing the code execution. And we pass in the retrieve config, then we have the assistant agent, another assistant agent, and another assistant agent. And this is going to be a coding team. And so we can have certain agents that are retrieval, certain agents that are not, and they're all working together. And the way we actually kick it off is with the boss, and the boss is the standard agent. And there we go. Okay, so we talked about a few different types of agents so far. We talked about the conversible agent, which includes the assistant agent and the user proxy agent. We also talked about RAG agents, which have the ability to pull information from documents. And now, as of a few days ago, we have a brand new agent type called the teachable agent. And the teachable agent, you're actually able to give it information that it learns, stores in long-term storage, and has even after the chat conversation ends. So typically, if you're giving information to an agent,
Hold
it
up.
doesn't have that information once
fuck
that
did he
task
just
is
say?
from document standard agent. And there we go. Okay, so we talked about a few different types of agents so far. We talked about
I'm
the
getting
conversible
bored.
agent, which includes the assistant
Getting
agent.
bored of what?
Oh, fucking
And the
AI.
proxy agent. We also talked about RAG agents.
This nigga's
which have the
bored.
ability to pull information
Like,
from
I've been doing this
documents.
shit since,
And
like,
now,
9 in the
as of
morning.
A few days ago, we have a brand new agent type
Been
called
doing it. I think after you messaged me. Yeah. Around fucking 11. That's when I woke
teachable
up.
agent. And the
I was
agent,
asleep,
you're actually
dog, the
able to
whole
give it
fucking night, the
information
whole
that it
morning.
learns, stores in long-term storage,
fell asleep
and
at like
has
12 at night.
even after the chat
And I was just
conversation
out,
ends.
bro.
So
I couldn't wake
typically,
up, dog.
if you're giving information to
I woke up
a
around
teacher,
8.
it doesn't have that information once that task is completed
Yeah, I
or
couldn't
once
wake
that
up, bro.
chat is closed. But now with the teachable agent, we
I
can
think because I
always
was
call the
learning a
teachable
lot
agent,
yesterday
which will
too.
have that information forever. And so we
Yeah, you guys
define
wanna
a
play
teachable
Marvel
agent in the
Rivals?
same way we define other types
This
of
guy.
agents. So right here, just like that. But rather
You
than
wanna
saying
play?
user proxy agent or assistant agent, we use teachable
You wanna
agent.
play Marvel
And we
Rivals?
have this teach config. And for the teach config, we have a few parameters. We have the verbose